Hey, hopefully you guys are all aware we're going to be talking about the main differences between hammer mills and roll crushers, and exactly some of the benefits and the challenges you have with each machine, and hopefully you get some answers as to what's good for the application you're working on. Just to be fully upfront and some disclosure, we have people from a wide variety of industries attending today. So everything I say might not be applicable to exactly your process, and that's okay. And I will be a little vague at times, or I may be talking about an industry that really doesn't relate to you. So just keep that in mind that I do have to be a little vague and broad here. There probably are going to be times the vast majority of people attending today are grinding grain. So I may focus there a little bit, but I do understand that there's people here grinding different minerals, rocks, different metallics and whatnot, so in plastic. So that's okay. And if you do have a specific question, like I said, feel free to ask that. I can go over that after. But the presentation overall, I'll try to keep it broad in that sense. So one of the first things we typically look at when differentiating between a roll crusher and a hammer mill, and I just remembered one disclosure I want to say, this is labeled as hammer mills and roll crushers. I may slip up and say roller mill, we may say roller grinder in there. All of those terms are synonymous for for this presentation, so don't get too hung up on there if it's a roll crusher, roller mill, roller grinder, whatever it is. Those are all the same machine for what we're talking about today. But one of the main differences I look at with these machines is the energy consumption, and that's a big one. As you guys are all familiar with your facilities, energy costs are very real, very important. We have to look at them. Here are just a few examples. I kind of brought up the top graph shows everything in horsepower, whereas the bottom graphic is showing everything in kilowatts. Again, I understand we have people from all around the world, so trying to make it easy to read. But you can see there's some pretty vast differences. Depending on how fine you are grinding, you'll see that energy consumption almost get cut in half. Um, Hammer mills are great at getting to a finer grind, whereas roller mills are better for a coarser grind. However, there is a fair amount of overlap we see in that. So that's the point of this webinar today, is in that gray area where you can use both machines. We do want to look at what's best, and the first thing we're looking at here is the energy consumption. Now, here I'm calling out the energy to grind. I'm showing US #2 yellow corn, and I'm showing the mean particle diameter at both, or at 400, 500, and 600 microns. That's just the average. That's not showing anything on actually the distribution. So I know there's quite a few people here that actually look at the full distribution. This is just looking at the mean particle diameter. We will dig a little more into that. So this is a sieve report or the particle size distribution from a hammer mill grind. And it's something we'd very typically see. You can see some larger material on the 4 and the 6 mesh, but you also see an uptick of fines down there on the right side of it, which is very common for hammer mills just because of the nature of how they grind. I'll talk about that in a second. But then we can compare it here to the distribution of a roll crusher or roller mill. You can see you have a lot of the material really stacked up here on the 8 and the 12 and a little bit on that 16 mesh screen. I'll go back, we can kind of look at that hammer mill. You can see it's a little wider distribution, whereas on the roller mill or roll crusher, you can see it really concentrated in one area. I do want to point out this roll crusher is looking at a average of about 1,400 microns, and that hammer mill is right around 1,200 microns for mean particle diameter. So relatively similar grinds, but you can see there's a big distribution change. So roller mills have a lot more concentrated distribution when it comes to your grind size. So a lot more uniform grind, more homogeneous. So if that's something you're really after, roller crushers tend to be a little better machine there. We can control our grind size a lot better. And the reason we can do that is because of the roll speed differentials that we use in those machines. Now, those rolls are not actually spinning at the same speed. Usually, I will say there's always going to be the exception to the rule, but for the most part, we're going to put a roll speed differential on that machine. So the front roll and the back roll are spinning at different speeds. And what that creates is a shearing or cutting action within that machine. Instead of just the rolls running at the same speed and squishing the material, we're actually cutting it. And that cutting action really allows us to have a lot of control on where exactly that material is going to end up on your distribution. Certainly there are other variables. I've done a webinar on the variables of a roller mill. There's another half a dozen variables that'll come into play, but the biggest one is that shearing action of the rolls that allows us to really control where our particle sizes are going and get a much more uniform grind. Whereas on a hammer mill, we don't have as much control because it's just a violent impact between that hammer and the material as it gets into the grinding chamber. So I show a sieve report here. Mean particle diameter is about 350 microns. But the big thing I want to show you why you get a wider distribution with hammer mills is because your larger material is a result of your screen hole size. So it doesn't matter how big your screens are, you're still going to create a lot of fines, but the screen size is really controlling your oversized material. It's just not allowing the large particles through because so much of the grinding happens before the material even sees the screens on a hammer mill. So you can see there on the far right, there's quite a bit of material less than that 270 mesh screen or in the pan. It's showing 17.5% of the material from the sample would be considered fines. And most of those fines were created before that even saw the screen. So the fines are a result of the high tip speed of the machine, as well as the hammer quantity in there. So you can control those. If you've watched my hammer mill webinar, this is a couple of variables I go over. The quantity of hammers and the tip speed is what's going to control the fine side of your distribution, whereas the screen size is what's controlling your overs. So because you're making so many fines, we see a lot of people try to use a larger screen to get a coarser grind. And really what that mostly results in is getting more oversized particles. So you do see your average particle size go up, but your standard deviation is going to get larger, and you're not going to have as uniform of a grind. So when it comes to, and I guess here I do overlay them to kind of give you a better example. This is two distributions, one from a hammer mill, one from a roll crusher. Both are approximately 700 microns in mean particle diameter, but you can see looking at the graphs, they are vastly different grinds. Again, the roller mill or roll crusher is going to have the most of the material concentrated in this 10 to 40 mesh range, whereas the hammer mill is just kind of everywhere. So again, that roller mill gives us the cutting advantage to it, whereas a hammer mill is literally taking a hammer, swinging it, whacking the material, and you're just getting a lot of oversize, you're getting some medium size, and you're also getting a lot of fines. So with this slide, one thing I always talk about is, again, the averages are almost identical. They both average right at 710 microns, but if you do look at the graph, they are vastly different. So again, I'm saying so a lot, I'm sorry. But understanding what you want out of the grind. If you just look at an average, you might not be comparing the right thing, but if you look at the whole distribution, overall, the roll crusher is going to be a better option there. It's going to give you a lot more control of the particles you're looking at. You want to minimize overs or minimize fines, it's a great machine to look at. The next thing we'll talk about is the heating of the product, just because with the nature of how the grinding happens, you have some attrition in there. We do see an increase in the temperature. We typically do not see as high of an increase with the roll crusher. Usually no more than 5 degrees Fahrenheit as an increase. Whereas hammer mills, because there's a lot more attrition inside that machine, we do see the temperature rise a little more, 5, maybe all the way up to 15 degrees Fahrenheit, which increased heat is going to drive off more moisture. So for those people here that are grinding grain, mostly in the feed industry, you're going to see increased shrink off of hammer mills just because you are creating just a little more heat as compared to a roller mill. It's not huge, it's a few degrees more, but it is something. And a lot of what I've covered over the last 10 years I've been doing these things is it's the little things that add up and they become big things. Looking at a couple questions here, I see someone just asked on loss in moisture. For the most part, and just to make sure we cover it, as moisture does decrease within the product, we do see an increase in fines as well, just because drier material grinds easier and we see more fines. Jorge has a question on variable frequency drives with Hammermills. I will talk about those later. That is a great question. Another item we all have to keep in mind, and it's not necessarily due to the performance of the machine, but the ergonomics and safety of all our employees, is the sound levels. Hammermills are louder than roll crushers. I see show a couple examples right here. You can see the picture on your left is I took both of these. We're right by a Hammermill, which was right at 100 decibels. I know a lot of facilities do require both earplugs and ear muffs on top of them, just because Hammermills, they are very loud. That's just the nature of what they do. Whereas on the right, you can see a roll crusher that's only about 80 decibels. And certainly depending on what you're grinding and the environment of where they're installed, those numbers will change a little bit. But for the most part, we usually see Hammermills are at least 10-ish decibels higher than that of a roll crusher. Now, the aspiration systems we use, this is a really big topic I like to talk about. With Hammermills, we want to use that aspiration to pull the product down into the grinding chamber and then out through the screens. So we're using that aspiration not only for dust collection and housekeeping, but also for throughput. We're helping pull that ground material out of the grinding chamber. Roll crusher does not require aspiration for capacity or throughput reasons. Whether or not you have an aspiration system on that roll crusher, your capacity is not going to change. However, they still do provide benefit, for housekeeping reasons, but also the bearing life. Just because of where the different seals and everything are placed in the roll crusher, if you do have positive pressure inside that roll crusher, it is going to try to push material out through the different cracks and spots in the frame, one of which is right where your roll shafts are coming through. So we do see an improvement in bearing life on roll crushers when you are using the aspiration system, because we're not pushing that dust right into where those bearings are located on the machine. But even still, the aspiration system for that on a roller crusher does not have to be the same size, I'll say pound for pound, of that of a Hammermill. So it's a much smaller system. You're collecting less dust. You don't have as much material to handle. So when you are looking at the differences between a Hammermill and a roll crusher, you do need to consider the aspiration system. That's another fan you have to put on your system. That's more connected energy you're going to have to pay for. There's more maintenance to it. So you have to look at your capital costs there. You're also your operating costs, and even potentially if there's some air permitting that has to be done with adding an air system to these. And then even the last bullet point I show on the bottom is with a Hammermill, you're collecting all these fines. You have to do something with them. You have to reintroduce them back into your stream of product. Whereas as a roller mill, you may not have to do that, or not as much. There's a less volume to look at there. So again, all things to consider, but overall, I'd still say the roll crusher is the better machine here, just because while yes, we don't need aspiration for throughput, it still does provide a benefit, but even so, it is a much smaller system, easier to manage and maintain than that of a Hammermill. Vibrations. First off, just the first caveat there, both machines, when they are in good working order and well maintained, should have little to no vibration. However, what we typically do see is that Hammermills are more susceptible to vibration issues, simply because you have a very large rotor spinning very fast. Not all Hammermill rotors spin this fast, but some of the biggest ones in the market spin up to 25,000 feet per minute, or 129 meters per second. That's a large rotor moving very fast. It takes just a little bit of imbalance, and that rotor can start to shake on you, and you can have issues. Whereas roll crushers, the fastest most of those rolls are moving in there, and it's a smaller diameter even, is about 3,500 feet per minute, or 18 meters per second. Certainly, and then on top of that, just the way your wear parts are wearing inside the machine. On the hammer, or on the Hammermill, those hammers can wear easily, or if you get some foreign material, it can take a chunk out of that hammer, which is going to increase the vibration on it. Whereas with the roll crusher, you just have the roll. You can chip a little bit of the corrugation off, but it's not going to be a large weight. So you're not going to see an imbalance immediately. So it takes just a little bit of uneven wear, or some foreign material, and you can really throw that Hammermill out of balance very quickly. So again, if they're well maintained, it's not an issue, but We've seen plenty of vibration problems over the years just with different installations people have. Another thing to consider with roll crushers is the heavy lifting that's involved. You know, those rolls have to be recorrugated and reconditioned on a frequent basis. Certainly will depend on the product you're grinding, how often you're running the machine. But you know, I see there are some people that have to change out the rolls every few weeks. There are some people that measure that timeline in years. So again, it really depends on what you're looking at. But even still, those rolls are very heavy. If we look at our 16-inch diameter by 52-inch long roll, that roll can weigh almost 3,000 pounds. There's a safety risk with having that amount of weight suspended in the air. You know, so that's something you have to take into consideration. I don't know exactly how you put a monetary value on it, but there is an increased risk. There's some ergonomic factors there. Whereas changing out the hammers and screens on a hammer mill, while yes, you have to do it a little more frequently than changing rolls, they're much lighter pieces of equipment. So, you know, you may have some stuff that's really heavy, and with heavy stuff, you might have to get a crane. Sorry, wrong crane. We might have to get a crane involved, which is going to add some cost to your operation. So, you know, again, we're looking at operating costs there. What kind of crew do you have to bring in and change these parts out? So things to consider are, what are your labor costs to change each of those? Yes, you're changing your screens more often, but they also don't take near as long as like a roll change. So I kind of give some rough numbers. I think most of you probably know what your times are, but screen changes are hopefully taking everyone less than an hour. Your hammer changes can take 1 to 3, really vastly depending on the size of your machine. But the roll changes, well, yes, they're not as frequent. They can take a lot. They do take a lot longer, I should say. And if you have a 2-roll crusher, you're looking at a couple hours. But if you have a 6-roll crusher or a triple pair machine, that you know could take upwards of 20 hours, again depending on your installation, where it's located, what you all have available to you. So again, this isn't exactly related to throughput, but this is really going to weigh in heavily on what your operating costs are. So this is totally ignoring what your capital costs are to purchase this equipment, but the amount of operations you're going to have to do long-term to maintain this machine. But on top of that is not just maintaining the machine, is also managing the machine while it's running. For the most part, hammer mills are kind of a set it and forget it machine. I don't like to say that. I don't want you guys turning on your hammer mill and leaving it. I'm hoping you're doing your due diligence and checking on it, pulling samples and really keeping an eye on it, making sure it is running properly. But they are more set it and forget it than what a roll crusher is. Roll crushers, we really want to make sure you're managing that properly. You're taking samples, and not only just one sample. With roll crushers, you almost want to take one on each side of the machine, both the left side and the right side, and then you can take them on every bank of rolls you have. You don't have to do this every hour, but it is something I encourage just to make sure that machine is running properly. So we do see roll crushers, you know, we've talked a lot of benefits earlier. This is one of the more disadvantages is it does take some additional management or even attention from some employees. So, you know, if you're a facility that you just don't have a lot of manpower, you don't have the extra time to be checking on this machine and making sure it's set up the way you want to, you might lean more towards the hammer mill instead of the roll crusher. You know, like I said, labor costs, labor supply, that's the big thing. If you don't feel like you have the quality employees that can maintain this, that's something you have to take into consideration. I guess, yeah, I skipped a few of the things on the roll crusher, but roll parallel, for the most part, once you get those rolls in parallel, they should stay there, but you still need to check it and make sure they've stayed there. The roll gaps do change. If you pull sample, you can change that roll gap. That is one advantage of the roll crusher, is you can easily change your roll gaps while you're operating, whereas instead of like a hammer mill screen that you have to turn it off, lock it out, and change it. But the biggest one really is maintaining the motor loads. You know, if you're looking at a triple pair machine or a 6-roll crusher, you have 2 or 3 motors, and you want to make sure you're balancing the workload on each of those motors evenly, as compared to a hammer mill when there's 1 motor and that's all you have to keep an eye on. So just a real quick question. I won't make you guys raise your hands or shout out your answers, mostly because I cannot see or hear you. But if you're looking to grind a very fibrous product, and I show wood chips here, you have the option between a roll crusher and a hammer mill. But as soon as you contact us and ask us, you no longer have an option. The roll crusher is not the machine for fibrous products. It's one of the bigger disadvantages there. Just they do not go through roll crushers very well. They get ground very little. So if you have something that's very fibrous, we're going to want to look at a hammer mill. I'll even say if you have product that has a lot of fiber in it, that can cause problems too. I've certainly seen some places where if just grinding corn, and if you have a lot of foreign material in there, some of the stalks and cobs, a hammer mill will chew that up pretty well, but that actually doesn't get ground up in the roll crushers, which can lead to issues downstream from there. So something to keep in mind, even if the material itself isn't fibrous, but you could get some fiber in there, it could cause some issues. So if you have a fibrous product or a lot of fiber in it, we might want to lean more towards a hammer mill or find other ways to remove the fiber from the material. So which kind of goes into some of the versatility of each of the machines. Hammer mills can grind almost any product. I say almost any because anything you put into a hammer mill will come out smaller than what it went in. However, there are a lot of products I do not recommend you put through a hammer mill. I'll say if you run a bowling alley and you want to get rid of your bowling balls, please don't put them through a hammer mill. You're not going to have a good day with that. But with the versatility, hammer mills can make both the coarse and a fine grind, like I kind of talked about at the beginning. And if you, again, go back and if you've had a chance to watch my webinar on hammer mills and the different variables that come into play, you can see there are a lot of settings that you can change in the setup of that machine to either get a coarse grind or a fine grind. So there is a lot of versatility there, but it kind of goes back to, there is still going to be a difference in energy costs and a few other variables. So that is one nice thing on the hammer mill is there is a lot of versatility to it. And then with roll crushers, like we talked about, we don't have the ability to grind fiber through there, but they also cannot grind as fine as a hammer mill can, which we kind of talked about right at the beginning. But they are more energy efficient, but they just can't grind as fine. So that's where we kind of get in that gray area of using both machines. With the hammer mill, a lot of those variables can be easily changed, especially if you're using a variable frequency drive. That's one of the questions I had was, with the hammer mill, can you use a VFD or a variable frequency drive to control the particle size and get similar results with the roller mill? And the answer there is kind of. That is one of the variables we can use is to alter the speed of that hammer mill rotor to slow it down potentially so you don't have as violent of an impact and you're not going to create as many fines. So yes, that is a variable we can use. I'll say it won't perfectly replicate it, but it will help quite a bit. You'll see a reduction in fines. But moving back to some of those variables with the roll crusher, really the only variable you can change to make it versatile is your roll gap, opening or closing the rolls. It's about all you can really do really quickly. Certainly we can change the corrugations on the roll, but that takes removing the roll, sending them in, lathing them down, recutting them. That can take weeks. Same with the roll speeds. Certainly if we're using a variable frequency drive, you can change them, or you might have to change some of the shivs or pulleys out. But again, we're looking at not a quick change. So there is some versatility to a roll crusher, but it has to be set up that way, or it can take some time to do it. Whereas a hammer mill, we can change a lot more of these variables relatively quickly. So in terms of versatility, I'll say a hammer mill is a little more versatile in the field, but there still is quite a bit of versatility to roll crushers just because, again, we can have one pair, two pair, three pairs. There's still plenty of variables to be used, but overall, I give the edge to the hammer mill here. There we go. A couple quick examples I'm going to show you just so we can kind of see where some numbers are. And again, you don't hold me to any of these. There's always a bunch of different variables that could come in, but this is one example I'm going to show. This is grinding US #2 yellow corn at 15 tons per hour to a mean particle diameter of 1,500 microns. And just looking at this application, these are two of the possible machines we'd look at. And really, I just want to show, you can see with the hammer mill, we have to use 75 horsepower, whereas our roll crusher is only going to need 60 horsepower. So right off the bat already, we have a savings in electricity, which I show on the bottom. your 3.5 horsepower per ton per hour as compared to 2.3 horsepower per ton per hour. Some people might not think that's a lot, but I went ahead and did the math for you. And if you are paying 10 cents a kilowatt hour and you're only grinding about 30,000 tons a year, that's still a difference of a little over $2,000 in electricity you're saving. Is it huge? No, but again, it's going to add up. And that's only grinding 30,000 tons. Certainly if they ran 20 hours a day and 350 days a week, that number is going to be a little over, it's going to triple or quadruple, so it'll get a lot higher. But another couple bullet points to look at there is, again, the roll crusher does not need an air system, whereas that hammer mill is going to need an air system, which is, we'll use about 1,500 CFM or cubic feet per minute, which is going to require you to, again, get some sort of a filter. You're going to have to get a fan for it. That fan's going to have a motor, which is going to add to your 75 horsepower. So see, in this case, there's quite a bit of electrical savings, just which is going to point the advantage to the roll crusher here. And then if we look at maintenance costs, again, these are somewhat arbitrary, but there can be some variances here depending on your application. But you can see also on it, just looking at roll recorrugation as compared to hammers and screens and changing those out. I don't include labor in this. I'm simply looking at material costs. But again, you see the roll crusher is a lower material cost on maintenance for 1 year as compared to what the hammer mill is. Again, there's still a lot more variables that each facility you'd have to take into consideration, but this is just what I'm showing you for now is this little information. Another example here is US number 2 corn at 350 microns. Again, I'm showing the same specs. You can see the horsepower difference. In this case, the hammer mill is actually going to use less because we're getting towards the finer edge of where we'd want to use a roll crusher for. That hammer mill starts to be more advantageous energy-wise because we have those high tip speeds. You're seeing that impact. You're creating those fines right off the bat. But again, this is just looking at an average of 350 microns. If you remember what we talked about earlier, that's just the average and not necessarily the distribution. So the average is the same, but that roll crusher is still going to have a tighter standard deviation or a more uniform grind. Again, you can see the rest of the bullet points. I won't read them all out, but in this case, the electrical on the roll crusher is higher over a 1 year span as compared to the hammer mill. So just highlighting everything we've talked about, this is just a real quick summary. I guess one thing I didn't talk about is, see, I have it on the roll crushers and the hammer mill, I guess, is the thermal event risk. With hammer mills, you have a very fast rotor, and then you have a contained grinding chamber. So it's the material that comes into that grinding chamber has to go out through the screens. So if you get some foreign material in there, some sort of metal that, maybe a piece of stainless that doesn't get caught by a magnet, that piece of metal is going to bounce around and get hit by that hammer until it can get itself out through the screens, which unfortunately sometimes can create an ignition source. And then you also have, depending on what you're grinding, you may have combustible dust in there, and it can create an unfortunate event. Whereas with a roll crusher, we talked about that those rolls are not turning as fast, so you have slower moving components in there. But also the way that those machines operate is if you do get a piece of foreign material in there, the rolls do have springs on them, so they may push open to allow the material through. But if that's not the case, they may actually just get stuck, and you'll just break your belts on your machine, and the machine will stop turning at that point. So you have a much lower risk of having a thermal event there. Again, it's hard to put a monetary value on that risk, but it is a risk. It is something that your risk management team does need to take into consideration when choosing between the two machines. So kind of the conclusion here, which is better, the hammer mill, the roll crusher, both. You can see a picture. Many of you hopefully know Mark Hyman shown here on the right. He always had a famous answer I always like to use. And the answer to every question is, it depends. Each of those machines does have its place in the market. You can see there's positives, there's negatives to both, there's challenges with everything. And a lot of it really just comes down to which of those variables that I've talked about do you place more value in? I can't make those decisions for you. I'm happy to help you get all the information, but based on the information that we discovered, you have to make the decision of which of those is better, which do you value more. I'll say there is a slight curveball we can look at, and I did mention both, is because you actually can look at both. There are quite a few people out there taking advantage of both machines and step grinding, which is just the process of putting a roll crusher above or upstream from a hammer mill. This is good for applications where you want to get a finer grind, but you would like to save some energy. Show pictures on the right of kind of the process the material would take. This is showing US number 2 corn. Certainly this can be very versatile to different products, but we're gradually stepping the grind down. And really what we're doing there is you're taking advantage of the energy efficiency of the roll crusher like we talked about. We see a big savings there, so we can grind part of that material with a very energy efficient machine, but then we still need to use the hammer mill to get the fine grind you're looking for. So we're going to save as much energy as we can by grinding with the roll crusher, but then we're going to come back and we're going to get the fine grind with the hammer mill. Depending on the application, we can see a reduction in energy consumption by about 25%. Certainly there's a lot of variables that come into play, but this is an option out there as well. I understand there's challenges with everyone with space requirements, but depending on what you're looking at, this can be a way to utilize more of the benefits of the different machines that we talked about today. So that's what I have for you today. Certainly we can open up to questions. I see another one in here I haven't got to, but I also ask that if you have suggestions for future topics you'd like us to talk about, to please leave them in the comments or reach out to me via email or phone, and we're happy to take those into consideration. Okay, let's see a couple questions here. We talked about the VFD, moisture. I have a third question. I'll reach out directly with that. That's one's a little harder to answer to the group. So I'll wait just another minute, see if any more questions come in. Like I said, certainly you guys are all welcome to reach out to me directly with any questions you may have from this. Here's one. Based on your experience, which is the parameter of loss with hammer mills? I'm not sure what you mean about that. Could you clarify your question a little there? Here's a question on comments on post-mix grinding, hammer mills versus roller mills. There's a lot of variables that can come into play here. One of the first things with post-mix grinding, one of the challenges I see is I don't like to put material through a grinder that doesn't need to be in there. All that extra material is going to do is wear the components in there quicker than necessary, especially if they're already fine enough. You know, with a hammer mill, if you're adding another 20% material that doesn't need to be ground, you're going to wear your screens 20% quicker, because that is still material that has to go through the screens. It's going to get impacted by the hammers. You might create a finer grind. But I guess more comparing hammer mill to roller mill, it's all going to be the same things we just talked about. The one challenge you could see is, just like I said, if you have anything in there with a little bit of fiber, the roller mill's not going to grind that up very well, and that could be stalks, cobs, or any other sort of fiber that you're getting in there. You're going to have a challenge with that. So a lot of it's going to depend on just what's in your ration and how it reacts to each machine. All right, well, I'm not seeing any more come in, so I'm going to wrap this up.